Today, Year 10, we are looking at energy stores and energy changes. The Do Now activity is asking you to name 8 types of energy. Pause the video and write down as many types of energy that you can remember. On the next slide, there will be a list of 8 types of energy that you can self-assess against. Progress indicators for today. For good progress, you will be able to state the law of conservation of energy, describe energy changes for common situations, outstanding progress, explain what happens to wasted energy in a given situation. Conservation of energy, there is a law that states that energy can be transferred usefully, it can be stored, or it can be dissipated, but it cannot be created or destroyed. The word dissipated means that the energy is spread out into the surroundings, and because of this, the energy becomes less useful. Energy can be stored in a different lot of ways. For example, when an elastic band is stretched, its elastic potential energy increases. If you lift an object off the floor, its gravitational potential energy store is increased because you're gaining height. On this slide, we can see the 8 different energy stores. We have magnetic, thermal, chemical, kinetic, electrostatic, elastic potential, gravitational potential, and nuclear. For each one, there is a description. I've also given you some examples. Pause the video and make notes on the different types of energy with a description and see if you can come up with some extra examples. Okay, so for good progress, we need to show some energy changes for common situations. So the question that we're now going to answer is what energy transfers happen to a bungee jumper after jumping off the platform. So let's have a look at the changes in energy with the bungee jump. In position 1, you can see that the bungee jumper isn't moving, so it doesn't have any kinetic energy. The rope is slack. What he does have is a height, is a store of GPE. Between position 1 and 2, as the bungee jumper starts to jump, his gravitational potential energy is transferred to kinetic energy because he moves closer to the floor. At position 2, the rope tightens, the jumper slows down, it's a force that slows them down, and as the bungee is pulled back up, the GPE increases because he's gaining height. The kinetic energy decreases because he's slowing down, but the elastic potential energy increases. You can see in position 3 that the bungee does not return to its original height. Can you think about why? What might have happened to the transfer of energy? So the bungee jumper does not return to the original height, and this is because the energy is transferred to the surroundings as thermal energy. On the next slide, have a look at the diagram and make some notes about the transfers of energy in a bungee jump. So now let's apply our knowledge of energy changes to the tasks. There are 5 tasks in total. For each task, answer either in your book, on paper, on Word, or in whichever format you prefer. When you get to the task, pause the video so that you can complete it. After each task, there will be the answers. You can then self-assess in red and green pen.